Hello students, so today we will learn stoichiometry based questions, calculation based on chemical equations like this. So 50 kg of nitrogen and 10 kg of hydrogen are mixed to produce ammonia. Calculate the amount of ammonia formed and identify the limiting reagent in the production of ammonia in this situation. So how do we solve this kind of problem? The first step should be to write a balanced chemical equation. So what is the process here? Nitrogen and hydrogen are getting mixed together to form ammonia. So let us write it: nitrogen gas plus hydrogen gas, and they form ammonia gas. But this equation is not balanced. On the left hand side there are two atoms of nitrogen, but on the right hand side only one atom. So I will write 2 here, so it becomes 2 nitrogen on both sides, but still it is not balanced because 2 to 3 6 atoms of hydrogen are on the right hand side, but only 1 into 2 atoms of hydrogen on the left hand side. So to make 6 hydrogens on the left hand side, I will put 3 here. So now I think this equation is balanced: 2 nitrogen on both sides, 6 hydrogen on both sides. Okay, that's good. So this is balanced. So from here what we can write now, so this number here, if nothing is written here, that means it is 1. So this means 1 mole of nitrogen and 3 mole of hydrogen give you 2 moles of ammonia. So let's write it: 1 mole nitrogen and 3 moles hydrogen produce how much? 2 mole ammonia, right? We can also write this information in terms of mass in gram also. So what is the molecular weight of nitrogen? Molecular weight of nitrogen is 28. So 1 mole nitrogen means 28 gram nitrogen, because molecular weight represented in gram is called its 1 mole. So 1 mole nitrogen means 28.0 gram nitrogen, and 3 moles of hydrogen. So 3 into what is the molecular weight of hydrogen? That is 2 times 1.008, so that will be 2.016 gram hydrogen, and they will produce 2 mole of ammonia. So 2 into what is the molecular weight of ammonia? That will be 14 plus 3 into atomic weight is 1.008, right? So this much gram ammonia. So let's write it in simplified form. So 28.0 gram nitrogen, and what this will be? 3 into 2.016. Let's calculate it. So 3 into 2.016, so this is 6.048 gram hydrogen, and that produces 3 into 1.008, this is 3.024 plus 14 is 17.024 into 2, that is 34.048 gram ammonia. I am not rounding off any number here in the intermediate steps. So now we have this much nitrogen requires this much hydrogen to produce this much ammonia. So here in the given question, how much nitrogen and hydrogen we have? In the question we have 50 kilogram of nitrogen, means 50,000 gram of nitrogen we have. And how much hydrogen we have? 10 kilogram hydrogen, means 10,000 gram of hydrogen we have, right? So let us see which is the limiting reagent here, means which is present in the sufficient amount and which is present in less than the sufficient amount. So from the question, from this information we just wrote in the upper step, we know that 28.0 gram nitrogen, that requires how much hydrogen? 6.048 gram hydrogen. So let us see here, for this 50,000 gram nitrogen, how much that will require, how much hydrogen that will require, because 28 gram requires 6.048, so 1 gram will require 6.048 divided by 28.0, and therefore 50,000 gram will require into 50,000 gram. And let us solve this. How much that will come? 6.048 into 50,000 divided by 28.0. This is coming 10,800 gram hydrogen. So if you want to get completely 50,000 gram nitrogen reacted, then you will need 10,800 gram of hydrogen. But how much hydrogen we have available? Only 10,000. So hydrogen is present in less amount than the required amount. So hydrogen here is the limiting reagent. So this is the way to find limiting reagent. And suppose another situation which is not present here. Suppose hydrogen would have been more than 10,800, like 11,000 gram of hydrogen. Then what will happen? All the 50,000 gram nitrogen would have got reacted with sufficient amount of hydrogen, but some hydrogen would have got left out, which will not react. So in that case, all the nitrogen would have got consumed. Then nitrogen would have been your limiting reagent, right? So here hydrogen is limiting reagent and nitrogen will be not completely reacted, so some nitrogen will be left out after the reaction, which would have not got reacted to form ammonia. Okay, so here we got that limiting reagent is hydrogen. So total hydrogen will be reacted 10,000 gram. So from the upper reaction we wrote the information like 28 gram nitrogen and 6.048 gram hydrogen produce 34.048 gram ammonia. So from here we can write that 6.048 gram hydrogen produces how much ammonia? 34.048 gram ammonia. And in our reaction, how much hydrogen is getting reacted? All the 10,000 gram of hydrogen, right? Because that is present than less than the required amount. So 6.048 gram hydrogen produces this much ammonia. So 10,000 gram hydrogen will produce. So now the product will be decided by the limiting reagent, right? It is always the case. Your final product amount will be decided by the limiting reagent. So all the limiting reagent will get reacted and that will determine how much product will be formed. So from here 10,000 gram hydrogen will produce how much ammonia? So 6.048 gram produces 30.4.048. So 1 gram hydrogen will produce 34.048 upon 6.048 gram ammonia. So 10,000 will produce into 10,000 gram ammonia. And let us solve this. How much this will be? 34.048 divided by 6.048 is equal to this into 10,000. This is coming 56.296. 296 kilogram. So it is in gram. I have divided by 1000, so it becomes kilogram. So it is nearly, you can write 56.3 kilogram ammonia will get formed in this reaction, and that's the answer. So I hope you would have enjoyed this question, and if you're liking my videos, you can consider subscribing my channel and sharing these videos with your friends also. So we will meet again with some other interesting problem. Till then, take care, bye bye, and thank you very much.